Another application of the second derivative is the second derivative test for Extrema. And you have the first derivative test that allows you to check for whether a critical point is a local maximum or minimum, but you can also, in some cases, use the second derivative test. Here are the cases in which you can, here's the information that you can pull from that second derivative. If you've got a critical point, and the second derivative exists at that critical point, when you evaluate the second derivative there and get that it's positive, that tells you that f of c is a local minimum. If you evaluate the second derivative at c, the critical point, it implies that, and you get that the second derivative is negative, then f of c is a local maximum. And if you get that the second derivative is equal to 0, then the test is inconclusive. So let's jump right into this test. To use this test, we're going to need the second derivative. So let's take the first derivative of f. That's 5x to the fourth minus 20x cubed. And the second derivative is 20x cubed minus 60x squared. And let's write that in factored form for our convenience. I'm going to factor out a 20x squared. I'm going to be left with an x and minus a 3. So we need the critical points. And how do I get critical points? Those are the zeros of the first derivative. I'd like that one to be factored as well. So let's factor out a 5x cubed. I get x minus 4. The critical numbers are x equals 0 and x equals 4. Okay, let me scoot that over a bit so you can see all of that. Okay, so now how do we use that second derivative test? Well, we found that x equals 0 is a critical number and x equals 4 is a critical number. And now we need to evaluate our second derivative at 0 and 4. So the second derivative evaluated at 0 is the easiest form to evaluate it in, is just 0. And so the test is inconclusive. The second derivative test is inconclusive. All right, second derivative evaluated at 4, which was the other critical number, is going to be 20, I'm using this form now, times 4 squared, 4 minus 3. I just plugged in 4. And really, I don't care what numerically this evaluates to be. I just want to know its SIGN sign. 20 is positive. 4, when I square it, is positive. 4 minus 3 is positive. That's positive. So what does the second derivative test tell me? That f of c is a local maximum. So f of 4 is a local max. Whoops, did I do that wrong? Local min. Yeah, I did it wrong. That happens. So we got that the second derivative evaluated the critical number, which we found using the first derivative. The second derivative evaluated at this critical number is positive, so f at 4 is a local minimum. Okay, so what about the other critical number, 0? It's where the test was inconclusive, we just use the first derivative test. Use the first derivative test to determine if that's a max or a min. And do you remember how to do that? Think about it for a second. To use the first derivative test, you already know that x equals 0 is a critical number, and then you check the SIGN 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 of the first derivative to the left and to the right of 0, and a little interval to the left and to the right of 0. Okay, and if you're not quite sure how to do that, give it a try first, and this example is completed for you on page 220 in your text.